Okay, good afternoon, students. Let us continue with properties of triangle. 4 mark questions, as I said yesterday. And we'll finish off today 4 mark questions of properties of triangle, and we'll go for long answers of functions. Theorems are important, no? Those theorems we'll do. Now, if A is equal to B plus C cos theta, then show that sin theta is equal to 2 cos A by 2 into BC by B plus C. Okay. Same yesterday we did, no? What is given? Sin theta is equal to, what is given? A is equal to B plus C cos theta. Cos theta subject A by B plus C. Cos theta subject A by B plus C. Now we know that cos square theta plus sin square theta is 1. Sin square theta is equal to 1 minus cos square theta. Sin square theta equal to 1 minus A by B plus C whole square. Sin square theta equal to 1 minus A square by B plus C whole square. That is nothing but sin square theta equal to, take LCM, B plus C whole square minus A square. You take LCM B plus C whole square. Is it clear? B plus C whole square LCM by B plus C whole square. Now sin square theta is equal to, this is B plus C plus A into B plus C minus A square minus B square. This is in the form of A square minus B square, which is A plus B into A minus B. By B plus C whole square. Now sin square theta is equal to, this is 2s minus A by B plus C whole square. Yesterday only I said all the formulas. Now that becomes 2s minus 2a. That becomes 2s minus 2a. That is equal to sin square theta is equal to 2s into 2 common s minus A by B plus C whole square. Now sin square theta equal to 4 s into s minus A by B plus C whole square. Sin square theta equal to 4 multiply and divide with BC, B plus C whole square, s into s minus A by BC. So multiply and divide with BC. So sin square theta equal to 4BC by B plus C whole square into, this is cos square A by 2. What is cos A by 2? Cos A by 2 is under root of s into s minus A by BC. Is it clear? That is nothing but sin square. Now remove that square. Is it clear? Sin theta is equal to plus or minus 2 root BC by B plus C cos A by 2. Is it clear? So that is your answer. It's very, very important for 4 mark. Next. If cot A by 2 comma cot B by 2 comma cot C by 2 are in arithmetic progression, then prove that A comma B comma C are in AP. Then prove that A comma B comma C are in AP. Is it clear? So what is given? Cot A by 2, cot B by 2, and cot C by 2 are in AP. What it is given? Cot A by 2, comma, cot B by 2, comma, cot C by 2 are given in AP. What is cot formula? That implies S into S minus A by delta, S into S minus B by delta, S into S minus C by delta are in AP. Cot A by 2 formula S into S minus A by delta, S into S minus B by delta. Is it clear? That implies S into S minus A. See, the ratio, the delta is the common part. This is delta. So delta gets cancelled. Is it clear? Right. That implies S into S minus B, S into S minus C are in AP. That implies this S is also common. S minus A, S minus B, S minus C are in AP. If they are in AP means what? 2 times of S minus B is nothing but sum of twice the middle is equal to sum of the extremes, correct? That implies 2S minus 2B equal to 2S minus A minus C. 2S gets cancelled. That implies minus 2B minus of A plus C. That implies 2B equal to A plus C. It implies A comma B comma C are in arithmetic progression. It is implies and implied by actual. Is it clear? Right. So if they are in AP, then A, B, C are also in AP. Is it clear? Right. Next. In triangle ABC, if 1 by A plus C plus 1 by B plus C is equal to 3 by A plus B plus C, then show that angle C equal to 60 degrees. Then show that angle C is equal to 60 degrees. So what is given? 1 by A plus C plus 1 by B plus C, 3 by A plus B plus C. 3 by A plus B plus C. Now take LCM. B plus C plus A plus C by A plus C into B plus C. And this is 3 by A plus B plus C. Now open the brackets and multiply here. That is 3 into A plus C into B plus C is equal to, this becomes A plus B plus 2C. A plus B plus 2C into A plus B plus C. That is nothing but open the brackets and multiply 3 times of AB plus AC plus BC plus C square. That is equal to A square plus B square plus 2AB plus 3AC 3AC plus 3BC plus 2C square. Open the brackets and multiply. Okay. Now That implies whatever the form, whatever the terms it gets cancelled, you please cancel it, right? So what I'm going to get here, 3ab plus 3ac plus 3bc plus 3c square. That is equal to a square plus b square plus 2ab plus 3ac plus 3bc plus 2c square. Now, if you observe the things, 3bc, 3ac, 3bc, 3ac gets cancelled. 3c square, you bring it to that side. 3c square, 3c square, you bring it to that side, and 2ab, you bring it inside. So what I'm going to get, 3ab minus 2ab is equal to a square plus b square plus 2c square minus 3c square. This is ab equal to a square plus b square minus c square. Means a square plus b square minus c square by ab equal to 1. A square plus b square minus c square by 2ab equal to 1 by 2. 2ab equal to 1 by 2. Both sides multiply with 2. Both sides divide, multiply with 2 in denominator or divide with 1 by 2, whatever. Then this is nothing but cos c equal to cos 60. This is nothing but cos c equal to cos 60, right? And c equal to how much? 60 degrees. This is your cosine rule formula. This is your cosine rule formula, cos c. So cos c equal to 1 by 2. 1 by 2 is nothing but cos 60. Is it clear? Next. If cot a by 2 is to cot b by 2 is to cot c by 2. That is equal to 3 is to 5 is to 7. Then show that a is to b is to c, 6 is to 5 is to 4. What is given is cot a by is 2 is to cot b by 2 is 2, cot c by 2 is 3 is to 5 is to 7. That implies cot a by 2 is s into s minus a by 2 is to s into s minus b by 2 is to s into s minus c by 2. S into s minus a by delta. Delta is nothing but 3 is to 5 is to 7. Now, see here. Now I can cancel s and delta, s and delta, s and delta. So what I'm going to s and delta. So what I'm going to get, that implies s minus a is to s minus b is to s minus c is 3 is to 5 is to 7, which is nothing but that implies s minus a by 3, s minus b by ratio only 5 is to s minus c by 7. Let it be some proportionality constant k. Means s minus a equal to 3k, s minus b equal to 5k, s minus c equal to 7k. Now s minus a plus s minus b plus s minus c, 3k plus 5k plus 7k. S plus s plus s is 3s. S plus s plus s is 3s. Minus a minus b minus c is minus of A plus B plus C. This is how much? 7 plus 5, total 7 plus 5, 12, 12. Total it is 15K. Now 3S minus 2S equal to 15K. S is nothing but 15K. When S is 15K, therefore S minus A is 3K, and 15K minus A equal to 3K. A is 12K. Like that, S minus B is 5K, then B equal to 10K. And S minus C is 7K. S minus C is 7K, then C equal to S minus C is 7K. 15K minus 7K is 8K. Now what is asking? Ratio. A is to B is to C. Right? It is asking us to find the ratio. Next step I will do. That ratio A is to B is to C. That is nothing but 12K is to 10K is to 8K. That is nothing but 6 is to 5 is to 4. See, K gets cancelled. Yeah, K gets cancelled. 2 6 are 12, 2 5 are 10, 2 4 are 12. That is the answer. Next, show that cos A by A plus cos B by B plus cos C by C is equal to A square plus B square plus C square by 2ABC. Take LHS cos A by A plus cos B by B plus cos C by C. What is cos A? Cosine rule formula. B square plus C square minus A square by 2BC by A. Plus cos B means C square plus A square minus B square by 2CA by B. Plus cos C. A square plus B square minus C square by 2AB by C. That is nothing but B square plus C square minus A square by 2ABC. C square plus A square minus B square by 2ABC. A square plus B square minus C square by C will come and multiply here. 2ABC. See, is it your same LCM, correct? That is nothing but 2ABC is same LCM. Then you are going to write it as B square plus C square minus A square plus C square plus C square plus A square minus B square plus A square plus B square minus C square. Correct? No? Now B square, 1 B square, 1 C square, 1 C square, 1 A square, 1 A square. So what is left out? A square plus B square by 2ABC. That is left out. A square plus B square by 2ABC. That is left out. Is it clear? The next most important and almost all next most important is show that 1 by r square plus 1 by r1 square, 1 by r2 square plus 1 by r3 square. That we have to show it as a square plus b square plus c square by delta square. Is it clear? Now take your solution. LHS 1 by r1 square plus, sorry, 1 by r square 1 by r square plus 1 by r1 square, 1 by r2 square plus 1 by r3 square. What is 1 by r square? Actually, r means delta by s. I will write all the formulas once again. Here, r means delta by s. Delta by s minus a. Delta by s minus b. Delta by s minus c. So, r square, delta square by s square. Delta square by s square plus 1 by delta square by s minus a whole square. 1 by delta square by s minus b whole square. 1 by delta square by s minus c whole square. Now s square by delta square. Bring it to numerator by delta square. S minus b whole square by delta square. S minus c whole square by delta square. Now delta square is the same common LCM, correct? The delta square is the common LCM. That is s square plus s minus a whole square plus s minus b whole square plus s minus c whole square. Is it clear? Now start simplifying. Open the brackets. A minus b whole square. So your delta square is your common LCM. So a square plus s minus a whole square, a square plus a square minus 2as. Again a square plus b square minus 2bs. Again a square plus c square minus 2cs. Is it clear? So that is nothing but s square plus s square plus s square plus s square, 4s square. Correct? Minus 2s common here, here and here. Minus 2s common, what I get is a plus b plus a square plus b square plus c square. It's whole divided by delta square. It's whole divided by delta square. That is 4a square minus 2s into 2s plus a square plus b square plus c square by delta square. Now 4a square minus 4a square plus a square plus b square plus c square by delta square. These two gets cancelled. A square plus b square plus c square by delta square. A square plus b square plus c square by delta square. Is it clear? Last one, which is also very important in 4 mark. And with this, the properties of triangle 7 mark and 4 mark has been done. And we are going to start functions. 1, 2 theorems will finish off today. Tomorrow functions theorems will be done, which you will get one long answer. Then we'll start mathematical induction. Okay. Right. And with mathematical induction, your long answers will be done. Okay. All 7 long answers I have done. 6 trigonometry transformations long answers. Those who failed is not suggestible. Is it clear? Right. So always you concentrate 2 long answers in matrices. 1 from properties of triangle, 1 from mathematical induction 4, and 5th one is either from functions or product of vectors. This should be your target. Next, prove that 1 by r minus 1 by r1, 1 by r minus 1 by r2, by R minus 1 by R3. That is equal to ABC by delta cube. That is equal to 4 capital R by now see the solution. LHS 1 by R, 1 by R1, 1 by R minus 1 by R2, 1 by R minus 1 by R3. This is your LHS. Now, again, check कर दिए. So R means delta by S. 1 by R means S by delta. R1 means delta by S minus A. So S minus A by delta, reciprocal. Again, S by delta minus S minus B by delta. S by delta minus S minus C by delta. So delta is your same LCM. S minus into minus plus A. Delta is your same LCM minus you multiply inside. S minus B into plus B. The delta is same LCM S minus plus C. Now your S gets cancelled, correct? Delta is your LCM minus you multiply inside. Minus you multiply. This minus you multiply inside after taking LCM. Now what is left out? A by delta into B by delta into C by delta, which is nothing but ABC by delta cube. You got your first result. And in your second result, ABC, okay, delta is equal to ABC by 4R. Correct, no? And delta is, R is equal to delta by S. And delta is equal to RS. This also will prove it, right? Now, ABC, I will make it as subject. These are your basic formulas. ABC, I am going to replace it as 4R delta. ABC, I am going to replace as 4R delta. Divided by delta cube means R cube S cube. R cube S cube. Okay. R cube S cube. Okay, you do one thing. Instead of R cube S cube first itself, ABC is 4R delta by 1 delta cube. 1 delta gets cancelled, delta square. Now this is fine. Then 4R by delta square. That is 4R by delta means what? RS means R square S square. That's it. So with this, your properties of triangle 4 marks and 7 marks has been done. Now let us do theorems. Functions theorems, then I will do mathematical induction. Is it clear? Already 4 very important theorems, right? If you learn these 4, usually he is giving from these 4 only. Okay. Usually he is giving 4 and 1 or 2 extra different questions. But also we'll do to be on safe side. Okay. 4 theorems are very important. Now let us start with functions. Functions 2 marks has been taught already. Only 4 marks. Is it clear? Theorem 1. Now what it states, theorem 1 statement, if F is mapping from A to B. G is mapping from B to C. B bijections. B bijections. Then prove that. G circle F mapping from A to C is also bijection. Okay, right. See the proof. Now listen carefully. What he has given is F is mapping from A to B and G is mapping from B to C are bijections. That implies F comma G are both 1, 1 and 1, 2. F comma G are both 1, 1 and 1, 2. Now, to prove G circle F is 1, 1. Correct, no? Now, so the G circle F is mapping from where to where? So G circle F is mapping from your G circle F mapping from A to C is what we have to show 1, 1 is 1, 1 function. To prove G circle F mapping from A to C is 1, 1. Now for that, for every A1 comma A2 belongs to A, then its images with respect to G circle F. Then G circle F of A1 comma G circle F of A2 belongs to C, where A is your domain and C is your codomain, right? So A1 and A2 are belongs to the domain elements A. Then its images, always images with respect to the function G circle F. That is G circle F of A1 comma G circle F of A2. Those are the images of A1, A2 belongs to C. Then what is exactly 1, 1? Exactly 1, 1, what it says is F is mapping from A to B means now for every A1 comma A2 belongs to A, then its images F of A1, F of A2 belongs to B. Then what you have to show? Images are equal. Images are equal. That implies elements are also equal. Images are equal. That implies elements are also equal. This is what you have to show, right? So now G circle F of A1 is equal to G circle F of A2. I took the images are equal. That implies G of F of A1 equal to G of F of A2. But G is mapping from where to where? B to C. And G is 1, 1 function, correct? So next step, that implies what I got actually? G of F of A1 is equal to G of F of A2. The next step, I am going to write it as F of A1 equal to F of A2. Why? Since G is 1, 1. Now, with respect to G function, if it is 1, 1, then the elements must be equal. So for G, what are the domain elements? F of A1 and F of A2. Means F of A1 must be equal to F of A2. For F of A1 and F of A2, what are your domain elements? A1 and A2. So that implies A1 equal to A2 since F is 1, 1. Since F is 1, 1. So therefore, G circle F of A1 equal to G circle F of A2. That implies A1 equal to A2. I showed it. We didn't write directly. We proved it. Next, to prove G circle F mapping from A to C is onto. For that, what is given? F is mapping from A to B is onto. Means for every B belongs to B, there exists A belongs to A, such that f of a equal to b. Why I'm writing directly like this? Because he said f is onto. Because what he said, f is onto function. Means for every b belongs to b, there exists at least one a belongs to a such that f of a equal to b. Okay. Next. Here only I will write. Given G is mapping from B to C is also onto. Is also, it's given, is also onto. Is also onto. It means what? For every C belongs to C, codomain element, then there exists a unique B belongs to B. Then there exists a unique, then there exists at least one B belongs to B such that G of B is equal to C. Because F is onto, we got F of A equal to B. Since G is onto, for every C belongs to, now G of B. Now, so for every C belongs to C, I was having G of B equal to C, correct? Now, G of, but what is B? Yeah, B is nothing but F of A equal to C. Means G circle F of A equal to C. For every C belongs to C, I constructed this part. That G of B is C and G of F of A is C. Means G circle F of A is also C. Therefore, for every C belongs to C, then there exists some A belongs to A such that I showed you just now, G circle F of A, what we got is C. I didn't write G circle F of A directly C, students. First I took G of B equal to C because it is true. And instead of B, I replaced with F of A because that is also true. Now G of F of A, you write your composite definition. That is G circle F of A. That's all. Is it clear? So therefore, G circle F mapping from A to C is onto. Therefore, G circle F is mapping from A to C is both 1, 1 and onto. That implies G circle F is mapping from A to C is bijection. Is it clear? Once again, you can have a look. You can go through it. So functions, this is your 7 mark most important. Given F is mapping from A to B, G mapping from B to C are bijections. F and G both 1, 1 and onto. To prove G circle F from A to C is 1, 1. For every A1 comma A2 belongs to A, then the images G circle F of A1 comma G circle F of A2 belongs to C. Now you take the images are equal. G circle F of A1 equal to G circle F of A2. That is G of F of A1 equal to G of F of A2. For G function, F of A1 and F of A2 are domain elements. Since G is 1, 1, then F of A1 equal to F of A2. And for F, A1 and A2 are the domain elements. Then F of A1 equal to F of A2. Since F is 1, 1, already F is 1, 1, A1 equal to A2. So I got it. Next, to prove onto, F is mapping from A to B is onto. And for every B belongs to B, there exists some A belongs to A such that F of A equal to B. Like that G of B equal to C, because F and G both are onto functions. From there, I constructed this part like this. For every C belongs to C, G of B is C. G of F of A is C. Then G circle F of A is also C. Okay. Yeah, to do next theorem, the time is not sufficient. So some Okay, now to the next theorem, the time is not sufficient. Okay, now let us do one more sum. Tomorrow we'll continue with remaining 3 theorems. So one theorem is done. The remaining 3 theorems we'll do tomorrow. Now before that, let us do this one. If f equal to 4, 5, 5, 6, 6, minus 4, and g is equal to 4, minus 4, 6, 5, and 8, 5. If f equal to 4, 5, 5, 6, 6 minus 4, and g equal to 4, minus 4, 6, 5, 8, 5. Then first bit, f plus g, so many bits are there. F minus g, third bit. 2f plus 4g, fourth bit. F plus 4, all bits he won't ask, but for your understanding purpose, we'll do all the bits. F by g. Mod f. Root f. F square and f cube. These are your bits. Whenever I take first bit f plus g, so let us, before going for that, domain of f, you should find domain 4, 5, 6. What is domain? The ordered pair first elements are the domain. And domain of G, ordered pairs of first elements are the domain of G. Now domain of common elements, F intersection G, that is 4 and 6. First, these things you should know. Okay. Now, whenever I take two functions, the domain should be 4 and 6. That's all. So now, first bit, it is f plus g. F plus g, that is equal to, what is the domain elements for f plus g? 4. That is 4, f of 4 is how much? 5 plus you write, and g of 4 is how much? Minus 4. Next, common elements for f and g only you have to take. 6. For 6, what is the image of 6? Minus 4 with respect to f. And for g function, it is plus 5. Like this you are going to write. I hope you understood. Now once again repeat it. 4, 1, 6, 1. Once again I'm repeating. The first question is f plus g. F plus g means what? I want common domain for f and g. Actually, domain of f is 4, 5, 6. Domain of g is 4, 6, 8. What is your common domain? 4 and 6. Once you take 4, then f of 4, 5. In between what I'm having? Plus. G of 4 is minus 4. Like that. Is it clear? Yeah, next I will do f minus g also. F minus g. Common elements, 4. 4, 4 only, no? Common domain. 4. 4, now what is f of 4? 5. Minus I should do. Whatever the symbol I'm having, you put minus. And g of 4 is how much? Minus 4. Keep it in bracket. Next, 6, what is g of 6? Minus 4. Minus g of 6 is 5. Is it clear? Right. So that is 4, minus into minus 5 plus 4. Next 6, minus 4 minus 5. That is 4, 9, 6, minus 9. 4, 9, 6, minus 9. Okay, anyway, we'll continue remaining bits for tomorrow. And after finishing of this sum, tomorrow I will go for explanation of theorems. Is it clear, everybody? But whenever I'm having f and g, you should go for common. Whenever I'm having f and g, you should go for common domain. and f and g common domain is 4 and 6. So whenever you find f and g both functions, you should take 4 and its images, next 6 and its images. Is it clear? So tomorrow we are going to continue with this sum. I will continue tomorrow, and tomorrow I will continue with this sum. More bits are there, no? Only I did 2. Remaining 8 bits will finish off tomorrow, and remaining 3 theorems also will finish off tomorrow, so that we can start mathematical induction long answers. And that will be the last long answers chapter. And after that, inverse trigonometry, 4 marks, few I will do. And trigonometry also, few short answers I will do, which are very important, but we can't guess still. And that's all. With that, your 1A will be done. Okay, right.